lesson where we did these questions in class. I'm not sure how many of you read it, okay? But last lesson, I gave you all some questions to do in class. Okay, so just want to check the answers. Okay. So essentially, okay, for question 1A, this will be a good answer. Okay, so Amelia actually presented very neatly. Just typed it out, that's all. Okay, so not much difference from what she presented on the whiteboard itself. Okay, so I hope that you're able to get this answer as well. Okay. Then for question 1B, right? Okay, just want to point out, I do notice I was marking your WA yesterday. Okay, although I haven't finished marking yet. By the way, our absentees, Matthew as well as Joshua, see me after class, we decide on the date, okay? So, so for this one, okay, if you do quotient rule, okay, based on what it is on the textbook itself, they do provide a formula. The formula provided to you is actually something like that. Okay, essentially it makes the same, it's the same thing as for what I teach in class. I keep the bottom, differentiate the top. Okay, the top is actually represented by U, and then after that I keep the top, differentiate the bottom, which is represented by V. Okay, and then over V squared. Okay, presenting the answers like this is fine. You just have to be very careful about what you write. Okay, in this particular case, we're differentiating with respect to T, so actually instead of dx at the bottom, it should be dt. Okay, because if you write different wrong notation, it could be a room for mistakes, okay, to actually be penalized for presentation or something like that. Alright, that's the reason why, okay, I avoided teaching in this manner, because it is a breeding ground now, okay, for mistakes to happen. Alright, so that's why we just stick to keep bottom, differentiate top, minus keep the top, differentiate bottom over bottom square. Okay, which here you did accurately apply it. Okay, and then over here, okay, in case you don't understand, I actually did the whole algebraic manipulation out, okay, clearly over here. But essentially the answer will be this, okay, which isn't wrong at all. Okay. So I hope that you're also getting the same answer. Then for question 1C, which Eugene presented, okay, since the question already said fx equals to this, we just stick with fx, we just use f prime x, rather than to use dy over dx. Okay, no need to go and redefine. Alright, so I want you to learn different forms of notations as well. Okay, so stick with fx and then f prime x. Okay, I think that in the hurry when Yuzi was trying to place his answer on the whiteboard, he made some transparent mistakes. Okay, so therefore, if you saw his working on the whiteboard, there were these mistakes, okay, which I pointed out here. Okay, eventually the answer will be this. Okay, you need not go and expand it. Keeping it at this stage, okay, in this factorized form is perfectly okay. But if you expand it, you just have to make sure you expand correctly. Okay. Then 1D, likewise, I think maybe some of you will also make the same mistake. Question gave us R and A, so we are differentiating R with respect to A, so the notation to be used is dr over dA. So I want you to check your work, okay, make sure that you use dr over dA instead of dy over dx. Okay, so what Wayne did was that there was a mistake in this, copied wrongly, question gave minus, but it should be a plus. So it should be a minus over here, but he wrote a plus. Okay, so which resulted in errors, okay, being made consistently throughout. Okay, so therefore the final answer should be 3a squared plus 2a plus 7 over 2a to the power of 3 over 2. Okay, the denominator can be expressed in many ways, which I've expressed over here. Okay, numerator can only be expressed in its expanded form. Okay. Okay, but of course, if the question asks for a certain form, then you need to present in this particular form, okay. Then after that, the second last one by Jasper. Okay, this one, the application is keep the bottom, differentiate the top, which is x that gives us 1. So therefore, you didn't write the 1 here. Then after that, keeping the top should actually be just x. Okay, differentiate the bottom, we will get half x minus 1 to the power negative half times 1. So this was an error here. I believe he made the error accidentally when writing on the whiteboard. Okay, eventually the answer will be x minus 2 over 2 square root x minus 1 times x minus 1. It's completely possible for your answer to be expressed in this manner as well. Okay, so either one of these four options would be accepted, unless the question says otherwise. Okay. Final one, Jingxuan's answer is okay. Right? Your answer should actually be 5x times 3x squared minus 2 over all this. Denominator can be expressed in any of these manner. Okay? And right, so that's it, okay, for the previous lesson. Okay, now I want to just finish a few more questions. Okay, then we can be completely done with quotient rule. I just think 20 minutes, that's all to complete the chapter. What are these features for? Oh, okay. Okay, so dy over y equals to expressed in this manner, our quotient rule. K bottom differentiate top minus k top differentiate bottom square. Okay, so looking at exercise 12.4, question 8. Okay, but I want you to differentiate 1 minus x squared times square root x plus 3 with respect to x. Okay, so in order to differentiate this, you can let y be this if you want to. What I will choose to do is just put d over dx, 1 minus x squared, square root x plus 3. Okay, our square root 1 plus 3, x plus 3 is the same meaning as x plus 3 to the power of half. Okay, so we apply our product rule. Product rule says that we keep the left side, differentiate the right. Okay, followed by keeping the right side, differentiate the left. The left will only just be minus 2x, or rather negative 2x. Okay. So the question did not specify how, to what extent we need to simplify it. So I think the least that we can simplify it to, in terms of organizing it visually, is that we have this for the left side, and have this on the right side. Okay? understand what part 2 actually is trying to ask for. Okay, Ziyue as well as Jovia, okay, please make yourself awake. Jovia. Okay. Alright, so down here says quotient rule. So very clearly we need to differentiate. Okay, but that's not the main point over here. I want us to really understand what does finding the rate of change means. Okay, I've told you that dy over dx can be a representation of gradient itself. Okay, we link the idea of dy over dx to gradient. Okay, but for gradient itself, what are we trying to understand? Okay, we learned in E-maths that gradient, okay, means in set 1 or set 2, okay, we learned that it is rise over run, right? Okay, correct, that's our understanding of gradient. Okay, and rise, okay, so if I have a straight line, rise will be this and run will be this. Okay, so the rise is actually the difference in the y values, the run is actually the difference in the x value. The difference itself is also a change, okay? A change in the y value, a change in the x value, okay? So the idea of rate of change, okay, is somewhat similar to the gradient itself. We're changing the y values with respect to the change of the x values, okay? So that's why rate of change, okay, has the same meaning as finding dy over dx, okay? So it's just different ways of conveying similar ideas. Alright? Because later on when we go into further chapters, we will be looking at changes with respect to time and all that. Okay? So a very specific idea is gradient now, okay? But the general idea about dy over dx is that it is a rate of change itself. Okay, we're looking at change over change. Right? So going back to this, okay, with our y equals to this, okay, dy over dx will be keeping the bottom, differentiate the top, which we have already done so over here. Okay, so keep bottom, differentiate top, then minus away. Okay, keeping the top, differentiate the bottom, which is 3x squared. Okay, over bottom square. Okay, so part I helps us in simplifying the process of having to differentiate the top part, okay, with product. Okay. And now we have to go through the very tedious task of simplifying. Okay. So let's go through it step by step. Keep the x cubed. This one, let's change it into a single fraction. Okay, we have 1 minus x squared. Minus away this part 2x square root x plus 3. Multiply with 2 square root x plus 3. So that they can all share the same denominator. For everything else, we keep it the same so as to not confuse us. If you intend to squeeze all of this into one single line in your notebook, I'm very concerned, okay, that you can squeeze so many things in one line. Okay, it's a bit impossible to read. Okay, so continue to simplify. 1 minus x squared minus away 4x plus 3. realize that, right, you could have maybe skip and do away with this kind of complication, or if over here you simplify it into single fraction, then you read neater. Okay, but I did not, so therefore it looks complicated like this. Okay, it's really up to your personal preference, what you prefer to do. Okay, let me continue. I'm going to erase this part. Get x cubed. And then 1 minus x squared. That's all x squared. So, of course, you can see that the minus x squared and minus 4x squared will eventually give us a negative 5x squared. Okay, but we notice that down here will simply be just a fraction. Over here is not a fraction, and then it all lies above a denominator. Okay, come in. So, what we need to do is to actually make the top the same denominator so that we can have a single fraction in total. So, I have x cubed, and then 1 minus 5x squared minus 12x. So I'm going to make this have the same denominator. Leave it at this point here first, that you'll copy, that you'll follow the algebra first. So I see that in my numerator, I already made it into the same denominator. So I could actually just bring that denominator down into the main fractions denominator. So I addressed it the other time round, okay, whereby we know that half divided by 3 is the same as half times 1/3, which is also the same thing as half 3 here. So that's why I can bring the 2 down to the denominator and multiply it. So that's the logic over here. Okay. Then we simplify the numerator. Okay, I tell you what. Let's just stop here. Okay, let's not expand it. Yeah, gonna be very messy. Okay. So it's good enough to leave it like that already, yeah? Okay, you want to down here factorize x cubed out, you can by all means, okay? But let's not lose sight of what the objective of the question is, Objective of the question is, we want to find the rate of change value when x equals to 1. Okay, so that means I want the dy over dx value when my x values are all 1. Okay, so strictly speaking, do we need to go through all this to meet the answer of the question? The answer is no need lah. Okay, so because you can just sub in x over here, but the thing is that you need to be very careful. Okay, I know that it was a very painful thing. Okay, but I want you to recognize that it is not always going to be so easy. Okay, because what if the question wants you to find dy over dx and then leave it in single fraction? Okay, then we have to go through this task. Alright, so previously I've always left it as such. Okay, I didn't bring you through the whole simplification process. So I'm making use of this question to bring us through, okay, the whole algebraic process. Okay, if you make use of this and put in x equals to 1, you need to be very careful that you don't miss out any single x and all your brackets are put into place. Furthermore, this one, I think it will be a very tedious task to press in your calculator as well, because you will have one big fraction and then another fraction. I don't even know whether your calculator screen can occupy all of this or not. Okay, yeah. So that's why go through simplification now. Okay. Then now that x equals to 1, in fact we have it life easy because we know x equals to 1 means all these are just 1s. X to the power anything is just 1. So you can just simply press in your calculator 1 minus 5 minus 12 minus 6 times 0. Okay, then now it's 0 already. Okay, then after that 2 square root 4 times 1. Okay, so you can make your life slightly easier when you have it in this manner. Okay, because we know 1 to the power anything is just 1. So, and all when x equals to 1, dy over dx will be equals to negative 4. Okay. Pressing into a calculator can sometimes take up a lot of time, especially when there are so many things over here and you really want to insist on putting all the ones. Okay, then that will take up time. But if you know that 1 to the power 3 is just 1, you can just simply manually already calculate that it will be 1 minus 5 minus 12 and so on. Okay. Okay. Questions? Yes, Xu. Because you have the idea of weight and time. Okay, I think it's a good question. Right, Shen is asking, okay, which I think is a good question. Okay, thinking that rate of change, the idea of rate is that it must always be related to time. Okay, I want to clarify that rate does not always mean that it must be in relation to time itself. Although very commonly in English aspect, okay, we do relate the idea of rate to respect of time. So the rate of change of the distance, right, will actually be your, dt speed, distance equals to speed times time, right? Okay, yeah. So the idea of speed, right, okay, is the rate of change of distance, correct? Okay, speed means rate of change of distance, okay. But that is one aspect. But rate in a very general maths manner, right? Okay, it just means a change over something else. Okay, so actually in this case will be x. Okay, it may not always have to be time related. And the thing is that this question also never tell you what x means and what y means. X could actually mean time as well. Yeah. Okay, so just in a very general manner, rate need not always be related to time. Yes, Ashley. question, but I saw that question and I think that it will make all of us combust, okay, to flames. So I think there's not necessary for us to do the next question. Okay, so I'll just end off over here for chapter 12. Okay. I can sense a huge sigh of relief. Okay. With that, your exercise 12.4 work. AC 5 and 7. It shall be due on Monday as well. Okay. So now I'm going to return to you your WA.